Okay, good. So let's go to the assignment 2. Let me download this assignment 2 document. So maybe put it in the download folder. I already have one there. Okay, but anyway. So this is the assignment document, right? So this is a data. So I actually, this semester I make my data easier to deal with the smaller sample and fewer variable. So this first assignment, the first thing you need to do is create a data file. Okay, so we're using R software. And the R commander is just a package written using R, right? So it's a package in R. So once you run the R, you will also have to call the R commander package. Right? So R can be used in different way. You can actually write the R code just right on the R console to have R do something. But then you can also use the R commander. So it's a statistical package. So it's like a manual driven, you do mouse clicking, you can do a lot of things, right? So the first thing first, right? And in fact, in my, in this page, actually, this is the module 2. You have my instruction for R commander, right? So these are different things that you would do in this assignment, okay? Yeah, these are instructions for that, but I thought I'd maybe just take you through it, right? So the first thing is to create a data set. Now, R, you can actually, since you have this Word document, in fact, if you had Excel, right, you can actually copy these, this table of values, right, and open your Excel document. Okay, if you have an Excel document. Those who don't have Excel document, you can use a university's OneDrive, right? It has like a Microsoft Excel in there too. But anyway, right? So I use my the Excel on my computer. So I'm going to just paste it. So I paste my data, right? Now, when you're dealing with statistical software, while arranging your data, usually column by columns, there are different variables. So we have gender variables here, right? Gender variable, heights variable, arm span, right? And whether a student or a subject has allergy, certain type of allergy or not, okay? And then row-wise, each row is a case, so or subject, right? Information from a subject. So that's this is Excel's first row. I have the variable name, right? And second row start having your data. So the first subject is a male, height 156 centimeter, right? And also arm span, it's about 160 and no allergy. So this is the first subject and second subject and so forth. So this is usually how you arrange your data, how a data sheet look like, okay? And when you use Excel, Excel actually not exactly a statistical package, it's a spreadsheet, okay? But we can arrange data in this way. So if I do this, I save it. Let me just keep doing that. Maybe save it in download folder. I'm gonna call it maybe A1. Oh, I have A1 already. A1 data, maybe call it data. All right, so this is Excel data name, file name, A1 dash data. So I save that data, okay? Remember the first row has a variable name, right? And then after that, you have data. So this is one way to do it. Then I close it, I have the data there. So I'm gonna run the, R. So I click R, right? And when you run R, you have this R console. And from here, you can actually call the R commander, right? To run R commander software, you just type LIBRARY, library, open parenthesis, RCMDR, close parenthesis, right? It's case sensitive. So you start with cap R, then lowercase cmdr. This is a package name. In fact, if you want to run R commander, you have to type this R command, right? You hit enter. All right, it'll start the R commander. Okay, so are you with me? Are you able to open the R commander?
I'm with you.
Okay. Anybody has any question?
No, I'm good.
Okay.
Thank you.
Okay. Okay. Good. So here's the R commander. So you have different things you can deal with your data or do analysis and so forth. And now, actually, for importing that Excel file, you click Data and go down to Import Data, and you can select Excel file. Okay, now you notice if you have SPS data file or you have SAS or Minitab or Stata, these different type of data file you can actually import into this R commander, right? So what I was trying to do is import Excel file. So you can do that and enter name of the data set. So by default, it is they give you a name data set. You can change it to something else. I can call it data set 1. And this is the data set name within this R commander. Okay. And the say variable name is in the first row of the spreadsheet because you're importing Excel, right? It's a spreadsheet file. And remember the data we create, the first row is variable name. So that's true, right? So you have that check, right? Convert character data to factor. Okay, so if you have data that's character, right, it would be considered as a factor inside the R commander. And that name factor, right, factor variable is quite important when you're using R commander. So you have studied the chapter 1, right? You know that there are pretty much typically 2 types of data. One is quantitative, one is categorical, right? The categorical type of data in R commander, it's called factor data or factor variable. Okay, so I'm going to click OK. It'll ask you to look for the data, and this is the data, A1 data, right? I open it, and I hope it's imported. So it's a data set 1 has 30 rows and 4 columns. So you can click this edit data set button, right, to get the data editor, right? You see all the data are imported. Okay, so that's how you create a data file very quickly. If you have that data table somewhere, right, you can import it in Excel and do that, right? There's another way to do this. That is, if I highlight this, okay, and select this and copy. So when you do the copy, this thing is in the clipboard. And in the format that most of statistical software like, the first row is variable name and the rest of them are data, right? Column-wise, this column is a variable. So if you've done that, you come to R commander. If you click data, import data. Now the first option is text file or clipboard. So if your data is text file or something in clipboard, you can go through this. So click here. I'm going to do the clipboard. Okay. Variable name is in the file. Field separator. Okay, now var is actually data from the Excel table, right? So I guess clipboard is good, right? I don't think I need to worry about these. So click OK. Now it is called data set now, right? If you click this, you see data is also imported. I'm going to click that. If you click this button here, you'll be able to actually view the list of data set that you have opened, right, or created in R commander since you first opened the or turned on the R commander. So I click that. You see you have data set, you have data set 1. This data set 1 is the one that we first imported with the Excel file, right? Now this data set here now is the one that we just created using clipboard. Hope that makes sense, right? But either way, right, you can actually create a data very quickly, right? With the from the data you have in that data table. Okay, any question? Okay, so that's your first R data set, right? And of course, when you have the R data set created, it'd be a good idea that you save it as an R data, right? Right now, you just have it as a data set within the R commander. You don't really have an R data yet, right? So I click data and go down to active data set and go down to save active data set. Click that. And I'm going to call that maybe A1 data, but this time it is R data. Okay. So I click save. Now, if I go to my folder, look for download, there's an A1R data. This is not the one, this one, right? Here we have an Excel file and then we create an R data. Right? So this is the R data. When you have an extension .rdata, that's the R data file. So the good thing of that is once you have that created, next time you can just click data, load data set, look for that R data, and you can open that R data. You don't have to go through the import or anything because you already have an R data that R commander recognize can use directly, okay? So I'm not gonna do that because I have the data in there already. Okay, hope that makes sense. Okay. So I have the data ready. Now let's start doing some analysis, okay? First, some univariate analysis. So univariate analysis means I'm analyzing one variable, univariate, one variable. So I'm gonna make a histogram, right? And a box plot, these are all univariate. I'm gonna make a histogram and a box plot to describe the height variable, just one variable, okay? How do we do that? Well, go to R commander. You click graph. Now there's an option, histogram. So just click on that. It'll ask you, it'll give you a window and allow you to choose variable to plot histogram for, right? Now, it'll give you a list of variable that you can make histogram. Now, what type of variable you can make histogram? Numeric type of variable. So you have categorical variable. It won't be shown here. That's a nice thing of this R commander, right? Now, other software, it may give you a list of all the variable, and you may use a histogram to draw something that is not supposed to be, that you're not supposed to make histogram from, right? You only make histogram for quantitative. So anyway, so you have height here selected. You can click this option here to put labels, right? So you have x-axis and y-axis. Usually y-axis is frequency. So let me type frequency. And please, when you're labeling these variable, these axes, start with the cap letter to write your words, right? And of course, the x-axis will be where we're dealing with height, H-E-I-G-H-T, so labeling the x-axis, okay? And graph title, you can say histogram for height variable or whatever you prefer to label it, right? And then click apply. So you're going to use that, and then you have the histogram there. Now this histogram has a class width of 5, 155, 160, 60 to 65, and so forth, right? So that's cool. Now, you know this boundary. You have 155 and 160 and 165, right? Now, when you have a data that is 160, would that be counted here or the next one? Usually, most of the software, when they make the histogram, they will collect, organize information using interval that you define for classes, right? And usually it's left inclusive and right hand non-inclusive, which means 160 doesn't go into this class, 160 go to this next class, right? And I can't remember exactly what R does this, right? So we can actually, you see there are 5 counts here, frequency 5. 155 to below 160, are they 5 counts? You can go to the data to kind of double check to see whether that's true or not. 155 to below 160. So you have 60. Okay, so 160s. So actually, in this case, it is actually right inclusive, right? So let's go back to the argument. So that means it's right inclusive. So in this situation, the 160 is counted in this class. And that same thing. So 160, since it's counted in this class, it should not go into this next class, right? So the next class will be above 160 to 165. And this can be changed, right, in the R program for histogram, okay? So I'm going to just go back there and click OK, right? And in R Commander, you see there's 3 windows here, right? This first window actually gives you the R script, so which is exactly the R program that does the job. And because I click it several times, right? Let's just look at the last one. This width, this is from here to here, that's one R script or statement. So this one actually makes the histogram, right? So you can make changes. You see here, man here equal to something. This part here is that label. So if you change this, so histogram for height variable, if I just move the variable out of this, right? Delete that. If I run this again, I'm going to hit a histogram that label, the graph label of histogram for height without that variable there, right? So if I do that, I can run it right by highlighting that line that I want to run. So highlight that, click submit. If you look at the graph again, that variable is gone, right? This is telling you that, you know, once you run any R commander, do anything in R commander, the actual code or R program that does the job will be displayed in here. And you can highlight each of those lines to reproduce the same thing. Okay. And if there's any text output, it will be put in this output window. And the bottom, this text box actually give you message, especially if you have something wrong, it'll give you an error message here. Now, we open the data without any mistake or error, so it looked good. And it tell you that there's 3 rows and 4 columns, right? So that's histogram, right? So that's not too hard, right? So we also need to make a box plot. So you click graph, go down to a box plot. Where's here? Okay, want to make box plot for height variable. Again, there's this option, and you can actually label the x-axis and the y-axis. Now, let's do that first. I click OK, see what the box plot look like. Let's go this direction from vertical direction, and the height variable is in good shape there. So this is okay. You don't really have to do any labeling. But if you wish to change this, okay, you may want to say height in centimeter, then you can label this height in centimeter. So that's it. Okay. So when you have this graph generated, you can actually put it in your assignment, right? So I want you to copy and your graph, right, and put it in the space over here. You need a histogram and box plot, right? So let me do this. I have this box plot. If I do this, right click and copy either format is fine, right? Maybe bitmap, whatever. And then go to the Windows, Word, Microsoft Word, and right click and paste, right? Graph is paste, right? Notice that this graph is so big, so you definitely want to shrink it, make it smaller by dragging on one of the corner, drag and move. Now, if you have a graph like this, you see the label is so small. You don't want that, right? How to prevent that to happen? You should actually, in R Commander, shrink the graph here first. Make it small, okay? And then do the right click and copy. And if you go back to here and right click and copy and paste, you get a better graph, right? With the size that you like, and then also the label font size is reasonable, right? You can shrink it a little bit, just make the font size more closer to your the text in the document. Okay. Well, I missed the histogram. I should produce a histogram too. So let's do that histogram, I can highlight this. I don't have to go through that, highlight this. It should generate a histogram, right? So this is histogram. Size-wise is okay. Right-click, copy, put it here. Maybe before this, paste. So I got a histogram. Maybe make it smaller, right? So I have both of them here. Okay, hope it makes sense, right? Now, usually when you make chart, you want to label them, right? So I can do this. Down here, say this is figure 1. That's a histogram for high. And you can go down to the next. So figure 2 is in box called high. Okay. Especially if when you're writing your term paper, I like you to do this. So this is a proper labeling of a graph, right? Use a figure and figure number and with a short title here. Now for this assignment, I also like you to write a sentence below each of those graphs, just to describe what you see in your data, right? So I mean, in this one, oftentimes people want to see whether your data follow a bell-shaped pattern or not, right? No, this thing doesn't look like a bell shape, right? But just describe, right? Maybe skewed to the right, right? Then you can describe the skewness, okay? So that's making graph, okay, histogram. And the next one is making frequency distribution table for gender variable, okay? Gender variable is actually a categorical variable, right? Gender, you have male and female, right? So we want to make a frequency distribution table. Now gender actually has male and female, right? So you can do insert table, maybe, I wonder what happened. Usually when you do the insert table, let me do this. It should allow you to decide. Okay, good, right? So you have probably male and female, and you can report the frequency. I only ask you frequency, right? If I ask you relative frequency, which means the proportion, right? Then you can put in the relative frequency distribution, right? But how do we get these? Well, it's not hard, just in Argumenter. Come here, click on statistic, summary. You want frequency distribution, right? You have one variable, you want to look at the frequency distribution. Gender, just click OK. You get the frequency. In fact, you get the frequency and relative frequency, right? So you have 63% and 36% from female and male, and you have 19 female, 11 male, right? So you can come here. Male is 11, here is 19, and your relative frequency, let me make it, so you have male is 36.67% and female is 63.33%. So that's it. That's pretty easy, right? So that's a frequency distribution. Then you need to make a bar graph, right? This is categorical data. I want to make a bar graph. Click graph, bar graph, here. I want to plot gender. Again, like the histogram, you can click option to do the labeling. Okay, so x-axis, it'll be gender, right? Y-axis will be the frequency. I know it, right? So I just type that in, right? I'm going to leave this graph type out. You can do it if you want, right? And click OK. And you look at the graph. This is the bar graph. Okay. This is a frequency bar graph. I can right click, copy, come here and paste. Maybe here. You get the bar graph there. I can shrink it a little bit and call it maybe figures 3, right? Just bar chart for gender. Any question? It's pretty easy to use, right? It's a nice software and it's free. And the nice part of it is free. So that's univariate analysis. Usually when you have quantitative data, you make these kind of graph, right? You can also construct frequency distribution table like this, right? Of course, if you do that, you have to set up interval, class interval, like 150 to greater than 155 to 160 and greater than 160 to 165 and so forth. And you want to count the frequency, right? So to do that, in R Commander, you will have to do some recoding. Let's not worry about it at this point, right? But you can do some recoding and define different, like there are 6 different classes. You can define 6 different category of classes and then organize your information from there. Let's not worry about it now, right? So one variable analysis, that's what you do, right? Bivariate, you want to look at the association between 2 variables, right? So here, for 2 categorical variables, we can do cross tabulation of these variables. So I have gender and allergy, these are the 2 categorical variables, right? I can do cross tabulation. I click statistic and contingency table, a 2-way contingency table, right? So if you do that, you can create a 2-way contingency table, do the maybe gender versus allergy, right? Row variable and column variable. Usually when you're doing risk analysis, your risk factor will be the row variable, right? So your risk here is a gender variable. It probably doesn't make sense, right? But I guess people believe that gender may have some association with allergy, right? Different gender have different risk of allergy, right? So I click, you can click statistic. This is something that we will learn later on the chi-square test for testing whether the 2 variable has strong association or not. You can also ask to do the row percentage, right? Or column-wide percentage, or overall percentage distribution. I'm going to check the row percentage, right? And click OK. So you look at the contingency table, you cross-classify these 2 variables, female and male, and yes, allergy, no, allergy, and so forth, right? So, and then you look at the percentage, row percentage. So this is a female row percentage, the female row, right? So for female, it's allergy distribution. So for female, you have more yes, 57% yes, and 42%, about 58% yes, and 42% no. But for male, that's the opposite, right? You have more no and fewer yes. So row-wise, if you compare row by row, the distribution pattern are not quite the same. Generally, when you see a situation like this, that means it generally implies that there's some association between gender and allergy. Different type of gender, you tend to have different allergy distribution. Female here has higher rate of yes than male, okay? Okay, so this question really asks you to produce this contingency table, right? And also ask you to make a cluster bar chart. Some places call it comparative bar chart, right? So it depends on the author who wrote the book, right? Cluster bar is quite often used, but anyway, right? So from years, we probably just want to, you will need to create a contingency table. So let's try to do this, maybe something like that. Put a table in there. Female, and then male. Oh. And then say no and yes. I think that my table is not big enough. I should have also the label, right, for the gender. So this column is gender, for different category of gender, and then on top I probably should create another row, right? That's for labeling the allergy. But you can do that, all right? And I ask you to do a joint frequency. So this is joint frequency. This is the relative frequency. So look at frequency. No, it's 8, yes, 11, right? And total is 19. So I'm going to let you just finish this table, right? Be able to figure out the contingency table. But then you need also a cluster bar, right? So how do we do cluster bar? You click graph. There's this bar graph, okay? If you click on that, gender versus allergy. So you see a plot by groups. If I select gender and plot by group, I can then select the allergy, right, for different groups and click OK. So this will plot gender by allergy, right? Of course, there's that option again. You can actually do the labeling, right? So I'm going to, well, what did I do? Plot by group, allergy. Okay, and click OK. And look at the graph. So this is called stack bar graph, right? The two categories stack on top of each other, right? And if I click graph, bar graph, plot by allergy in option, and I check this side by side, this will give you the cluster bar. Okay, I prefer cluster bar than stack bar in this situation, right? So I click OK, look at the graph. This is a cluster, right? You have one cluster and two cluster bars. And in general, you want to look at the distribution. The distribution of this pink color and green color, are they different, right? If they're different, that means what? Or just by each of those clusters, right? For look at the female, the pink and blue or green, right? Depends on your computer. But here also the pink and blue and green, their distribution are different, right? So that means if you're in different gender, your risk of allergy is different. Right? So that means there's some kind of association between them. Right? So again, you can shrink this a little bit. Oh, doesn't look good, right? That legend. Maybe move it up a little bit. You can also opt to have that off, right? Usually, let me just do this. I'll copy that, put it in my graph, my document. Go back to your chart. Let me see. Okay, so if you go back to R Commander, you see how that bar graph is done. It's done this way. Okay, and there's this bar plot function, right? With the width embedded in the width function. So this bar plot actually is a R function. So a lot of people are writing different functions for perform different tasks, right? And then this bar plot function is for making bar chart, right? Often you can actually go to a web browser, right? Search for bar, maybe using that function name, right? You see bar plot with R, and R, that means you can find the bar plot function, and understand how to use that bar plot function, right? You see the documentation for it, right? So there are here the documentation especially, right? It explains how the different argument or parameter in that bar plot function you can use to do different things for that bar plot, right? So I'll let you explore that, right? But I often do that. When I saw R Commander give me something, right? And I would try to search for that documentation for that function, try to learn more so I can make changes on the graph, right? Removing the legend or change the size of the legend or something, or change the color, right? You don't like the pink and green. You want to make it maybe tartan or black and white, whatever. Okay, good. So that's a cluster bar and a joint frequency table. Okay, so that's good. That's for this one, right? Let me make it smaller. Okay. And scatter plot. When you have two quantitative variables, you want to understand the association, you make scatter plot, right? So if we go back to the data, these pairs of data. They're all quantitative. You want to see whether they have any correlation or not, right? So to do that, you click graph. So there's a scatter plot option, select that. And you plot one versus the other. Right? Again, they will give you the list of all the variables that you can use in making scatter plot, right? So I just do that and click OK. And got my scatter plot, right? So it look like it's a pretty clear linear trend, right? And positive linear trend. When height gets increased, arm spans increase. There's a strong linear correlation between the two variables. Okay. Let me show you one trick here, right? For some comparative study. If I do scatter plot, if I do plot by group and choose gender, and I click OK and plot, it'll actually do the plot and also label, actually I should say mark the data point that are from different genders. So for male, that's these red triangle markers. And female using the blue circular marker. So you can see the scatter plot for these two subgroups, right? That's a very useful tool. If you want to include another variable, especially categorical variable in your analysis, okay? So good, so that one, let me see, you can also copy and paste it in here, right? So it's not too hard. Now I'm gonna leave this to you, right? And in the my R instruction, let me see, the module 2, right? I actually have two options for you, two video clip, right? I can help you to actually make time plots, okay? In fact, you can also view all these other, just in case you forgot what I did here and you don't want to review this recorded lecture, you want to go into each of those, that's okay, right? You can just go there. So what I'm going to do is just continue. Okay, I'm going to skip this time plot. I'm going to let you do that, right? Then we're going to look at a descriptive measure, right? I guess this week is not yet for you to study descriptive measure, but I believe most of you have learned these before. Right? So what does mean? That's average, right? Standard deviation is a measure of spread. Variance is a square of standard deviation. Median is not a measure of center, right? It's a measure right at the center of the ordered list of data, okay? So we're going to do this for height variable. How do we do that in R Commander? It's very easy. Click statistic, summary, and ask for numeric summary, right? If you check that, want to do it for height, and click OK. You got them all. Mean, standard deviation, median is the 50th percentile, so that's this, right? It doesn't give you variance, but you know variance is square of standard deviation. So square this number, you get your variance. So you can answer all these 4 questions very easily, right? And there's a distribution of high data from this followed bell-shaped pattern. What you need to do really just look at the history, right, to see whether it suggests that the high variable likely to have a bell-shaped pattern, right? Now, here we only have like 20 pieces of data or 19 pieces of data, or maybe 30, whatever. It's really not a lot, right? For you to really understand the actual shape of a distribution, make good comment on shape of distribution, you really need larger data, 100 or 200 pieces of data, right? So here, just ask you to comment. You say yes or no and just justify your answer. That'll be good enough, right? And of course, you can answer these questions very easily now, right? We did it for gender. You can do it for allergy, right? We did this already, so you can answer this, right, with the frequency table you made. Now, this one is actually do a normality test. What is normality test? When we do statistical analysis, later on, we do statistical inference. Some of statistical test procedure are designed based on the assumption that your data is from a bell-shaped, or we call it normally distributed population, right? So before you try to apply those methods, you got to check whether that assumption is hold or not, right? Whether the data are really from a bell-shaped distributed population. So that's the purpose of this, whole purpose of this normality test, is for testing whether the data or height variable is likely from a bell-shaped normally distributed population. Okay. And there is a so-called a normality test. And this test usually, what I usually use is the Shapiro-Wilks normality test. And when you perform these tests, generally they will give you a p-value so that you can conclude the test. And usually what people use a p-value to conclude the test, they will use a 5% as a cutoff point for making decision. When this p-value is higher than 5%, usually p-value is presented in decimal form, right? Not in percentage form. So that means if you have a p-value higher than 0.05, then I'm going to accept the normality, which means I'm going to accept that the data is likely from a bell-shaped, normally distributed population. Okay, so we're going to talk about more how we actually formally test a hypothesis. Generally, when we do a hypothesis testing, we will set up null and alternative hypothesis, right? Null null means no difference or no correlation, right? Something like that. Here, probably that null is the distribution of population is no different from normal, okay? And when this number is too small, smaller than 0.05, p-value too small, smaller than 0.05, usually we will conclude that we're going to reject that null hypothesis. In this case, null hypothesis normality, so you're going to reject null hypothesis normality. That's when you have a p-value smaller than 0.05. If a p-value higher than 0.05, we're going to say your data support normality. Okay, so we can run that. I'm going to run that for you. Archimedes, quick statistic, summary, go down to test of normality. If you click on that, want to test what? Height, right? Click on height. Shapiro-Wilks options check. So if you click OK now, it'll give you a result from testing normality. So click on that. P-value is 0.018. So this number actually is not greater than 0.05. It's less than 0.05. So you're going to reject the normality, right? So the data is not likely for normally distributed population. Okay. Now, when you're answering a question like this, I'd like you to copy this result from your analysis into your Archimedes, right? So that can justify your answer. You don't just give me a number, right? You're going to copy this and put it in your document so that you can use that to support your answer, right? I usually like to make it new, right? And so the spacing will be correct. And make it maybe a blue color or red color, whatever you like. Right? So I can see, so you're gonna put the p-value over here, right? Showing me that you understand where to find that p-value. Then you're gonna write a conclusion about it, right? So that's it, that's a normality test, okay? And the rule again is if the p-value is less than 0.05, you're gonna reject the normality. Data is not likely from normally distributed population. If the p-value higher than 0.05, then data support the normality, right? Data is likely from a normally distributed population, right? Okay, the last one, finding mean, median, and sample standard deviation for high variable, for female subject, right? You want these measure of height variable from female subject. So that's easy too, right? If you click on our commander, remember we do the summary and numeric summary, right? For mean, standard deviation, and so forth. But if you do summarize by group, and the group variable is gender, if you do that, it'll actually calculate all the descriptive statistic for each category of gender. So if I click OK, you get that set of statistics for male and also female separately. So you can just use this information to put it in this place and answer the question, right? So this assignment, I think it's pretty simple, right? It's easier than the assignment I gave, I guess, previous semester. Anyway, so that's it. That's all you need to do for the assignment 2. Okay. Any question? Are we doing okay? Are you still there?
I had a quick question.
Yes. Mm-hmm.
So for number 5, how we reported the p-value that we put, would you like us to do the same thing for question number 6 when we find like the mean and standard deviation?
You just put the mean and standard deviation in here in this space.
Okay, you just want us to put the number. Okay.
Yeah, and then also support your number by copying and paste your R output in some place in there.
Okay, thank you.
Yeah. Okay. Same thing here, right? You have that line of R output, right?
Okay.
Just copy and paste. All right, good question. Thanks. Okay, so I think it's not too hard to use the software, right? What do you think? What do you think?
Yeah.
You doing all right?
The software is pretty cool to me. Seems pretty useful.
Okay. Yeah. A lot of you, I think it's going to medical field, right? And even when you get into residency, right? If you decide you just want to practice, right? But if when you're in residency, you may be involved in some research project too, right? That's probably a required component there. And often you need to do some statistical analysis. And this software is free. Okay, so it's good to know it, definitely, you know. Okay, any other question? Anybody? If no, then I'll let you go, right? I'm going to just, I will post this